Okay, so multiplying and dividing monomials. So first of all, monomials can be a constant, which is just a number, a variable, which is a letter that represents a number or an unknown value, or a combination or a product of a variable and a constant. All right, so let's go ahead with the first example right here. Let's say we have 7 to the third power times 7 to the second power. So these are monomials right here. So they're two factors. We're multiplying a 7 thirds times a 7, or 7 to the third power and a 7 to the second power. Basically what we do is keep the base and we add the exponents. So we get 7 to the fifth power. So this is simplified. This is simplified. Sorry. Now in the second example, it's 3 to the fourth times 3, and it says to evaluate. So it's basically the same steps. We will get 3, the base of 3, and we're going to add the exponents. But notice that the first 3 has an exponent of 4, and the second 3 does not have an exponent. So when it doesn't, it actually is an implied 1. So we're going to add 1 to that 4. So this ends up being 3 to the fifth power. So this would be the simplified part, but we want to evaluate it. So evaluating it means actually finding the answer or the value. So we're going to go 3 times 3 times 3 times 3 times 3. So we have to actually do the multiplication. Okay, so I already know that 3 times 3 times 3 is 27, and I know that 3 times 3 is 9. So I'm going to multiply 27 times 9, which gives me 243. Okay, we also can deal with variables. Like I said earlier, monomials can be variables. So here, our base is an m, so we keep the m, and our exponent is 8 plus 4. So it's simply m to the 12th, and that's as far as we can go. Now, monomials can have a product of a number or a constant and a variable, like in this example. So how do we deal with this situation? Well, we're going to multiply the negative 4 times the 2 together, kind of using the commutative property here. And we're going to take the base of x, since the x is the one with the variable, so we're going to variable with the exponent. So we're going to take the base of x and we're going to add the exponents like we've done before. So the 3 plus the 5. Okay, so as a result, we end up with negative 8 x to the 8th. There we go. And that is our answer. Okay, so now say we have a quotient of monomials, meaning we have a monomial being divided by another monomial. Same kind of concept, we have the same base, so we're going to keep our base. So in this case, our base is 6, and we're still going to do something with the exponents, but this time, since it's division, we are going to subtract the exponents. So we get 6, the base of 6, 7 minus 3, which is 6 to the fourth power. And this is simplified. If we wanted to evaluate it, then we have to multiply 6 times 6 times 6 times 6. So look for the words simplify or evaluate to let you know if you're going to do that. So both answers are fine. All right, so here, again, we have dividing monomials. And we have a 16n to the fourth divided by 4 to the nth, 4n. And remember, if there's no power, it's like to the 1 power. So what we do is we're going to have the 16 and the 4 dividing one another. And the base n, since they're the same, we're going to keep that n and subtract their exponents. So we have 4 minus, and remember, if there's nothing there, it is an implied one. So we get that right there. So 16 divided by 4 is 4, and we get n to the third power right there. All right, so here we have another example, 2 squared times 3 to the third power times 4 to the fifth power divided by 2 times 3 times 4. So we have 3 monomials that have the same base. 3 separate monomials that have the same base. So we just treat them separately but together at the same time. So here we're going to have the base of 2, and then 2 minus 1 times the base of 3, which is 3 minus 1, and then times the base of 4, which we have 5 minus 1, since all of those don't have exponents. So we'll go ahead and we get 2 times 3 to the second times 4 to the fourth. Okay, so we're going to go ahead and evaluate this. So this means 2 times 3 times 3 times 4 times 4 times 4 times 4. Okay, so 2 times 3, I'm just going to multiply 2 at a time. So 2 times 3 is 6 times 12 times 16 times 4. Then 6 times 12 is 72 times 16 times, which is 64. And then now we got to multiply these two big numbers right here, which gives me 72 times 64, which is 4,608. See, I had to do my little scratch paper over there.